So good evening. People are still logging in. We're up to 250 attendees, which is fantastic. I'm Josh Ginsberg. I'm the president of the Cary Institute of Ecosystem Studies. Let's just wait just a second and see if there's anyone else coming. But for now, why don't I just give you some background. First off, if you are online, could you go into the chat and just let us know where you're coming from, where you're sitting right now is what sort of we're curious where we are drawing our attendees from. Usually we have events at the Cary Institute. For those of you who are old friends, I probably don't need to say very much, but with 268 attendees and counting, I think I'll probably give a very short background. We're an independent research institute studying large-scale ecological processes and systems in and around Millbrook, New York. We work all over the world, in fact, from China to South Africa, Kenya, South America, and across the United States. We are focused in 4 areas of expertise. We work on freshwater ecosystems, urban ecology, disease ecology, and forest ecology, particularly the forests of the Northeast and temperate forests around the world. And so we'll talk more about that tonight. We do a lot of education and outreach as well. And so we have 2 series, one called Cary in the city in this case being New York City, and another called Friday Night at the Cary. But today we're not in the city, nor are we at the Cary, nor is it Friday night. So I'd like to welcome you to our new series, which we're calling the Cary Science Conversation. And this is the inaugural event, so we're glad you could make it. If you want to find out more about our previous Cary in the City and Friday Night at the Cary seminars and lectures, you can go to caryinstitute.org, C-A-R-Y institute.org, and they're all up there and posted, and there's some really excellent content there. I think what's amazing tonight is that we clearly have a lot of old friends, but we have a whole bunch of new friends. I see people from Moscow, Idaho, Dobbs Ferry, Santiago, Chile. So it's a global representation, and that's really quite astonishing for us. It's also nice to reach out to a whole new group of people globally, because we've all been in lockdown. So we're going to launch a couple polls. They're very brief, but as we do that, we just like to ask a couple questions. One is a very simple one, which is this your first time attending a Cary Institute event? Obviously, since we don't do virtual events very often, this would be the first time you'd attend a virtual event, but we're interested whether you've been either to a Cary in the City or Friday Nights at the Cary lecture. And as we do that, let me describe the sort of flow of events. There's a second question. Let me give you the result. I'll give you the results in a second. So the flow of events tonight is we're going to have a conversation. I'm going to talk with Dr. Charlie Canham, who I'll introduce in a second. At the end of our conversation, we'll have a Q&A. Please use the chat function, not the Q&A. We're going to close that down, but use the chat function to submit your questions. You can do so during the talk. In the Q&A, there's a second poll. What's your biggest concern about the future of Northeastern forests? So while you answer that, I'll finish up. So you'll submit your Q&As in the chat section, and then at the end of the conversation with Charlie, I'll pose some questions to Charlie from your questions. So let me just quickly introduce Charlie, but before I do that, let me just say we've got over 300 people participating tonight, and it's almost evenly split. 51% have never been to a Cary event before, 49 have. I think people may have be continuing voting. And so it's really great to have so many new friends at the other end of the Zoom. So in terms of the issues that you are most concerned about, invasive species, well, climate change wins. Invasive species, and climate has 44% of you, or 124 of you, feel that climate change is your biggest concern. Invasive species, 32%. Deforestation and logging, 13%. Deer, 9%. Fire suppression, only 4 of you, 1%. And so far, no one, oh, somebody has just jumped in. One person has jumped in on air pollution. So it's quite diverse, but climate change is clearly the winner, and we'll talk more about that and the impacts of climate change on northern forests. So let me just introduce Charlie. Charlie Canham is a senior scientist at the Cary Institute, and he's a distinguished global expert on temperate forests from New Zealand to New York. He grew up just down the Hudson, headed west to Montana State, which is in Bozeman, Montana, and then came east to Wisconsin for his master's degree, and then migrated back to New York to Cornell University, where he did his PhD. Charlie did his postdoc at the Cary Institute, and it's an interesting phenomenon. Many of our scientists started as postdocs and have never left. So several decades later, Charlie's still at the Institute and is still doing remarkable work for us. In addition to his academic pursuits, Charlie is devoted a lot of his time to the bettering of society through working for and on the boards of non-governmental organizations. Right now, he's on the board of the Adirondack Chapter of the Nature Conservancy, the Adirondack Land Trust, the Adirondack Council, Great Mountain Forest in Norfolk, Connecticut, and the Northern Forest Atlas Foundation. In addition, for any of you who have ever served as secretary to any institution, you'll have, it will resonate with you that for 6 years, Charlie was the secretary of the Ecological Society of America. The ESA, as we call it, is the largest membership organization for ecologists in the world. It focuses mostly on North America. And in addition to that, and maybe because of that work, Charlie was recognized with a Distinguished Service Award by the ESA in 2019. That was correlated with, but probably not caused by, the request that he lead the society's search for a new president, which he did very successfully. So that's just a bit about Charlie. You'll learn more about him and his interests in northern forests. But it's a pleasure and an honor to work with Charlie, and I'd like to welcome him to this inaugural Cary Science Conversation. So welcome, Charlie.
Thank you, Josh. Happy to be here. I'm sitting at home where most of us are, presumably, and delighted that so many people could call in. I suspect that, like most of you, we've all run out of things to watch on Netflix. And so I'm delighted to be here and hope to have plenty of time at the end to take questions.
Great. So Charlie, you know, most of us think that forests change predictably, right? You've got a field, you don't mow it, it turns into an old field and you get succession. And then maybe 100 years later, you get we think you'll get a fairly predictable mix of trees that is stable and dominated by a set of species that, given the ecology of the space, you might be able to predict. But the title of your book, Forests Adrift, sounds like a metaphor for forests drifting on the high seas with no real set course. So why are forests adrift?
Well, for many years, ecologists have indeed used a way of thinking about forests and the dynamics of forests in a framework of disturbance and recovery. In fact, in the very early years of the Cary Institute, there was a proposal that all of the research here should be organized around the theme of disturbance and recovery of north temperate ecosystems. And that framework does indeed presume that there's a recognizable and very predictable steady state that forests will return to if you just leave them alone. And frankly, there's a lot of comfort in this notion that of recovery to a steady state if we could just leave the forest alone. But to be honest, ecologists have been questioning that assumption for decades. And the silos of research that have grown up to understand the many different ways that human activities threaten our forests have struggled to put their work in any formal theory of forest dynamics, let alone one as simple as disturbance followed by recovery to a steady state. And over the many years I've been working on forests here in the Northeast and elsewhere in the world, I've spent time in many of those silos, and I've finally come to a conceptual model of how I think about forests under all the different currents that will shape their futures. And frankly, it does indeed largely abandon the comfort of the idea of even a hypothetical return to primeval conditions in favor of accepting that forests drift. Like forests, I'm learning to go with the flow and just try to understand where they're currently headed.
Great. And there is some comfort in accepting that. You know, people have been fascinated with this idea of a primeval forest, and as you say, it's a notion of nature that maybe preceded European settlement and the vast changes that European settlement brought with it. But in the book, you know, you sort of question that notion quite severely, and you've just explained why. But in a close reading, you do seem a little reluctant to let go of it entirely. So, can you make up your mind?
Yeah. Well, I have indeed learned to question just exactly what the pre-settlement forests look like. But I do believe that an understanding of the nature of the pre-settlement forests is still vitally important in all sorts of current debates about forest conservation and management. But any detailed look at the nature of pre-settlement forests reveals a much more dynamic landscape than is often imagined. And we have two principal sources of information about the nature of Northeastern forests in the 12,000 years since the retreat of the glaciers. The first is illustrated in the slide. I hope you can see. I'm sure it's small and hard to read, but this is an illustration of the work of paleoecologists who take a core from the bottom of a lake and then spend months to a year painstakingly extracting sediments at different depths, dissolving the sediment on a slide, and then counting the pollen grains preserved. The deeper you go in the core, the older the sediment, and with radiocarbon dating, you can build up a reconstruction of at least what pollen was landing on the surface of the lake since the lake was formed after the retreat of the glaciers. And what I've illustrated here are two of my favorite lakes. Heart Lake in the Adirondacks is at the foot of the high peaks, an area that's very near and dear to me. And maybe even more so, Sutherland Pond in the Hudson Highlands, where I grew up hiking when I was a teenager at West Point. So two very different forests and areas, with the Adirondacks representing a very northern forest, and the Hudson Highlands, Sutherland Pond, a very oaky forest. And I can stare at these diagrams forever. They're endlessly fascinating, and the nice thing is they're all available online. Any of you can go and download the data and find the lake nearest to where you live and look at what's happened for the last 10,000 years. And as you stare at those diagrams, it's pretty clear that a lot of the fluctuation you see reflects the fairly gradual but important climate change that's happened in the Northeast over the last 10, 12,000 years. In fact, if you really squint, there's a pulse of birch pollen about 10 to 11,000 years ago that almost certainly represents this younger Dryas era, the rapid cooling event after the warming that ended the Pleistocene, presumably due to disruption of the warm North Atlantic currents. But the two forests have very different patterns. At Sutherland Pond, oaks have been dominant for 8,000 to 9,000 years. The other species sort of come and go. One thing that isn't represented there is that there's also charcoal present all through the sediment at Sutherland Pond, reflecting the belief that light ground fires have always been important in the maintenance of these southern oak forests. The patterns in the Adirondacks are a lot more fluid, with species responding very individualistically. And again, as I said, most of what we see, I think most ecologists would say reflects, maybe with significant lags, but changes in response to climate. But the one really distinctive thing at Heart Lake is this really abrupt decline in hemlock pollen around 5,000, a little less than 5,000 years ago. It shows up in almost every lake you sample within the range of hemlock. There have been some suggestions that it could be a climate effect, but Margaret Davis, one of the pioneers of this work and a personal hero of mine, many, many years ago, suggested that this was the only example we have in the pre-settlement record of a species synchronously and abruptly almost disappearing from the landscape. And Margaret proposed that this was likely an insect that somehow got established here in the East that found hemlocks tasty and devastated the populations. And it literally takes about 1,000 years for the population to recover. But if you stare at that, you'll see that both hemlock and beech have been declining in abundance, even though they're still currently some of the most important species in those forests. They've been declining in average abundance for several thousand years. And so this is sort of a remarkable ability to understand what's happening. But we have an even more, perhaps just as difficult, but more detailed snapshot of what the forest looked like right at the time of European settlement in the form of what are known as witness trees. In order to sell the land off by the English crown or the early republic to settlers, you had to survey it, and you had to have a deed, and a deed needed a survey. And survey methods required that the surveyors record the species and size of the nearest tree to each corner of the lot. and with a lot of very diligent work. People like Charlie Cogbill in Vermont and Peter Marks, now retired from Cornell, spent years extracting this information from public records to provide a really detailed picture of what the pre-settlement landscape looked like. And what emerges is basically a largely unbroken old growth forest, dominated in the north by species, the most shade tolerant species like beech, sugar maple, hemlock, red spruce, and balsam fir. And in the south, massive oak trees dominated. And although there's still debate about the effects of periodic ground fires, we don't really know just how open that canopy was. So, you know, the bottom line here is that there was a very distinct and almost unbroken cover of forests at the time of European settlement, dominated by old growth forests. And yet it was a forest that reflected lots of change over the last 10,000 years.
And so now I understand why you're somewhat, it's not schizophrenic, but ambivalent about throwing out the idea of a consistent march to an end, because you do have these old growth forests, but the pollen record shows us the fluctuations and changes. And you know, we can get back to that discussion about loss of hemlocks maybe a little later. But clearly the forests were dynamic in a slow motion in pre-settlement days. So what changed after European settlement, and why is that so important for us to understand the next 100 or 200 years of forest drifting in the Northeast?
Yeah, this is probably an occupational hazard, but if you're a forest ecologist, you almost have to be interested in history, because you can't understand where a forest is going without understanding where it's been and how it got to where it is right now. This is, to a mathematician, forests are what we think of as computationally irreducible. You can't project forward without tracking every step along the way, because the past determines where you're going. And you know, the land use history in the Northeast over the last 400 years has caused massive transformations. But there's a very different history in the North and the South. The more rugged terrain of particularly the northern mountains, the Adirondacks, greens and whites, you know, limited the amount of agriculture that could happen just because of the steep slopes and rocky terrain. But those forests were aggressively and thoroughly logged, so much so that outside of the Adirondack Park, only a few % of forests in the Northeast were never logged. But perhaps unexpectedly, I argue in the book that wave of clear cutting, and in many areas the intense and massive fires that burned in the slash left behind, particularly once railroads were used for logging, had relatively little long-term legacy on northern forests. It was just sort of a pulse disturbance. Yes, the fires caused changes in soil chemistry and soil nutrients that persist to this day, but the forest recovered much more rapidly than in the South, where the land could be cleared. It was, and with an industriousness that's almost hard to fathom. You know, think of the earliest farmers in Dutchess County who purchased maybe 20 acres from the 9 partners, the land speculators, businessmen in Manhattan, who bought most of Dutchess County because the 250,000 acres they purchased had the last undeveloped river frontage on the Hudson in 1692 between Manhattan and Albany. And as they moved in from the river, they moved into wilderness and had to clear, often just by hand or with a horse and a plow, clear land to form that first farm. And so go forward 100 years, 150 years, and by 1900, 85% of the land in Dutchess County, where the Institute is located, had been improved, quote unquote, i.e. cleared of forest and put into agriculture. And because of that wonderful American tradition of local town historians, this story changes all through the landscape. But if you go and find and talk to your town historian or pull your local town history off the shelf, and if you read between the lines, you'll be able to piece together the timing and the pattern, what the crops were, when they started failing, and when farmers moved west. You know, but by the end of and so probably the low point for forests in Dutchess County was right around 1915. Go forward 20 years, the Great Depression, land begins to be abandoned en masse. And then over the past 80 to 100 years, forests have reclaimed that land, frankly, without any real active role from humans. It's really one of the conservation success stories of the last century, and the trees did it all on their own. and to the point that today more than 60% of Dutchess County is forested. You know, and the simple fact is that these post-agricultural forests that have emerged are in many ways distinctly different than any species mix that occurred in the pre-settlement forests. We still have lots of oaks here in southern New England and further south, but they're frankly only commonly found on land that was abandoned from pastures, because farmers often left scattered oaks in the pasture, both for shade for the livestock and because the livestock loved the acorns that fell. And so when those land pastures were abandoned, the acorns provided the next generation of oaks. But if a farmland was abandoned, oh, your dog is there, mine's next door. Lands that were cultivated fields before abandonment have a very different mix of species, limited to the species that with smaller seeds that could blow in from the hedgerow, species like the maples, ashes, birches, and white pines. And so the details of their agricultural history have set these two types of forests off on very different journeys. One of them may be coming back to what the oak forests were, but the other off on a trajectory that's entirely novel and unrepresented in the pre-settlement history.
So that, you know, make sure I'm unmuted. Yeah. So that actually is interesting. So you have the settlement, and from that, you know, 200-300 years cutting down all the trees. But as you say, we've now recovered that, and across the Northeast, you know, places that were forested are that were farmed are no longer. You see the stone walls throughout New England as testament to that. But I think our audience will be surprised to learn, as I was in reading your book, that roughly 60% of all the canopy trees that die in eastern forests each year die because they were cut down for logging. And my only thought was, who knew, right?
Yeah, no, I was as surprised as you are, and actually we discovered this through the work of an undergraduate intern in our research experience for undergraduates program. You know, to be honest, most ecologists study forests that are not subject to logging at all. You know, but logging is only legally prohibited on about 5% of northeastern forests, and for the remaining 95% of the forested landscape, logging turns out to be the overwhelmingly dominant form of disturbance. You know, but there's been a real sea change in forestry practices in the Northeast over the past 50 years. The public and even most ecologists assume that clear cutting is still the dominant form of forestry or silviculture. But on an area basis, at least, the most common logging operation removes only about 30% of the trees on average. But this plays out very differently in again, the northern forests versus the southern portions of the region. And in the North Country, one of the most dramatic changes in forestry has come from the divestment, the sale of all the commercial large landscape, large acreages of working forest by the traditional timber and paper companies, with that land purchased essentially by Wall Street. So real estate investment firms have bought this land typically on behalf of large institutional investors like pension funds that were simply seeking ways to diversify their portfolios. Now, this seems like a very strange thing, and how could they be interested in doing good forestry? One of the upsides here is that much of this land, through the effort of organizations like the Nature Conservancy and Open Space Institute and others, much of that land has been legally protected by easements that will keep the land as working forests and prohibit the fragmentation that comes from subdivision and second home development. You know, but these lands are indeed working forests, and so it shouldn't surprise anyone that they are actively managed, and in many cases fairly intensively managed. And while clear cutting is no longer the dominant form of silviculture on an area basis in the Northeast, it's on these large commercial forest lands where you're most likely to see clear cutting practiced. And for the simple reason that it's economical and it's cost effective. And I have to say that over the past decade, there are portions of the Northwoods where I see harvest levels that are getting to unsustainably high levels, and it'll be interesting to see how that plays out. But the story is very different outside of northern New England. There, small family forests make up the vast majority of forest land, and alongside scattered public ownerships in state and county forests. And the vast majority of the logging in these family forests is very light selective logging, often fuel wood cutting, firewood for home burning or for a local sale. Now, I have to say that most professional foresters worry that much of this logging is what they consider, quote, high grading, which is a cardinal sin to a forester. This involves simply removing the most valuable trees without concern for regeneration and the next generation of trees. I share that concern to some degree, but I think it misses the potential to rethink management of northeastern forests to find ways to develop new forestry that manages for both the really high value timber while maintaining the ecological and carbon sequestration benefits of mature, uneven aged forests. Now there's one other dynamic playing out here with forestry in the Northeast, and that's on some of the state and county owned forests, particularly in southern parts of the region, where there has been a resurgence of interest in intensive harvest and clear cutting. And the stated motivation for much of this appears to be create more young forest habitat for a variety of species of wildlife. There are a number of different groups that support this more intensive management, including deer hunters. And I don't want to, and I don't have the time to really get into the growing debate about the wisdom of this approach, but I will just say two things. The first is that the really diverse grass and shrub dominated old fields that developed on abandoned agricultural land were indeed remarkable habitat for a number of animal species that were quite likely very rare in the pre-settlement landscape, since that habitat simply didn't really exist prior to European settlement. And those grass and shrub communities are indeed disappearing as young forests become reestablished. But a recent clear cut is a far cry from those very diverse old field communities, and it's not necessarily the case that a recent clear cut recreates the habitat that those old field species of wildlife previously occupied. And the second point is that a new clear cut doesn't provide open conditions for more than a decade or two at most. And so in order to use clear cutting as the tool to maintain any meaningful amount of open habitat, you'd have to be clear cutting forests on a very short rotation. There seems to be this idea within some circles that a forest with 100-year-old trees is mature. Nothing could be further from the truth. An even age stand of 100-year-old trees is not even close to the maximum potential biomass or the structural diversity of a late successional or old growth forest in the region. And there's certainly no natural analog in pre-settlement forests for a landscape managed on a 100-year rotation.
Right, because the fires we had in pre-settlement were, on the ground and burned out the understory, but never really took out the canopy. Yep. So, and that would have been the only disturbance would have been at a scale other than glaciers scouring the entire landscape, right? But it's interesting as I go for my socially distanced walks these days. It's spring, and I can't help but notice that a lot of the shrubs, like honeysuckle, garlic mustard, are non-natives. They're abundant and they're invasive. And maybe it's just because spring is a time where, particularly at the ground level, you can see things that you can't see during the winter or during the summer. Sorry, but make it clear in the book that these invasive species are not the most serious threat to northern forests, but instead things like introduced pests and pathogens like borer beetles or ash blight, invaders that kill trees and don't compete with them are a far greater threat to northeastern forests. And I was just wondering, why is that? Because we think of invasive species as a really serious issue.
Well, there are lots of invasive plants. There are also invasive animals like earthworms that are an important threat in northeastern forests. There's no question about that. But with the vascular plants, it's important to remember that around 35% of the plant species in the Northeast are non-native. And most of these were actually deliberately introduced by European settlers and Americans, often for horticulture, but also for agriculture or forestry. And most of them went through a phase in which they spread into the landscape, became naturalized, and are now just recognized as part of our landscape. Most of the roadside wildflowers we appreciate are non-native. They often came over, presumably in the hay on the ships from the early settlers. But if you think about the understory of one of those post-agricultural forests, it went through this incredible diversity bottleneck where the trees, oddly enough, and perhaps unexpectedly, are the first of the native species to reestablish on that abandoned farmland. And they shade out that diverse and wonderful community of old field species. And for a number of years, there's almost nothing in the understory. And so, there are studies that suggest it could take years for the native forest understory to reestablish. And so, and in that time, you know, so the question is whether the understory is a zero-sum game. And it's not always obvious that the presence of something like garlic mustard is coming at the expense of a native species. I mean, you know, and there are limited resources to combat these things. So you have to pick your battles and decide. That said, you know, this highlights the value of deliberate stewardship and diligent efforts by local conservation groups and volunteers in most cases to limit invasives in the preserves and biodiversity hotspots. You know, I think we have to accept that in most of these species, we can't eradicate them, but we certainly, with diligent effort, can control the places that matter most. The woods behind my house definitely don't qualify as a biodiversity hotspot, but I have all 6 tree species of oaks in my yard. I'm quite proud of that. But I do find it oddly satisfying to weed out the flowering stems of garlic mustard that keep popping up. They're really easy to pull out of the ground. And since they're biennials, if you get them before they set seed and disperse their seeds, you can really make a dent in the population. But the slide that's up here now is what really terrifies me. And it's this, you know, I can be philosophical about the introduced plant species and hope that they, you know, naturalize without displacing native species. But these introduced pests and pathogens, you know, are just frankly depressing. And I take this very personally. The reasons for that intense color around New York is basically because the avenue for most of these invasives has been either solid wood packing material or the live plant trade, and all the importation that happens through New York is important. Plus, many of these insects and diseases are coming from a similar climate in China. They get here, the climate is similar, the species are often different, but they're similar enough that the pest or pathogen can attack them, and our species typically have very few defenses. So, you know, right now, emerald ash borer is just devastating all of our ash species. For us, that's really white ash and black ash. Black ash is an incredibly important wetland species. It's incredibly important to Native American communities. It's the ash that was used to make woven wood splint baskets. White ash, you know, you wouldn't, it's not a dominant species except on higher pH soils. It's a tree whose wood I really value for the boats I build. And it obviously is the wood used for Major League Baseball bats. Right. And you know, and so we tend to get into the trap of being asked to justify why is it critical that we're losing all of the ash species. And this insect, the emerald ash borer, disperses faster than anything we've ever seen, and more rapidly. There's no evidence of any ashes that are truly resistant to the emerald ash borer. And so, you know, there's just this long depressing litany. It starts with chestnut blight and Dutch elm disease and butternut canker and beech bark disease. There's now a disease attacking walnuts coming east from West Coast. There's a beech leaf disease that has me completely terrified. You know, in all of these, there's a common thread, and that thread is this importation problem. And if we go to the next slide, I just want to make a plug for a colleague of mine. Gary and I have worked together at the Cary for more than 30 years, and Gary will be embarrassed, but I will say he's my hero. You know, Gary and I are both forest ecologists. We're scientists. We like to study problems, but you know, Gary and I have both worked for many years on this issue of introduced pests and pathogens. And Gary finally decided he'd had enough and that it was time to get involved in trying to solve this problem. And so, working with a large group of collaborators around the country and in other countries, they have come up with an initiative called Tree Smart Trade. And I encourage anyone who's interested in this issue to go to the Cary website or Google Tree Smart Trade. You'll be able to find information. These are very sensible and feasible and economically viable proposals that could have an enormous impact on reducing the threat here. Some will get through, and I have to say that to me then the most important element of our defense is the human resource of people who are trained in the pathology and the entomology and the ecology. 20 years ago, I would have said we aren't training enough of those people, but I have to say I've been encouraged by the number of new graduate students I see going into those fields and blending together both the ecology and the pathology and the insect ecology in order to try to find ways to stop this. It's, there are no silver bullets here, but it is, to my mind, and I think to most forest ecologists' mind, the single most pervasive threat we face.
Well, so we've covered tree pandemics, which people can clearly relate to. And we've talked about, human disturbance and cutting down trees. The other one that was the top concern of our audience was climate change, and it's sort of the other elephant in the closet. Interesting in the book, as depressed as you are about forest pests and pathogens, you seem almost optimistic in your conclusions about the sensitivity of northeastern forests to climate change, or at least in the next century. So over what ecologically is a relatively short time frame. So could you talk about why you think that northeastern forests might be a little more resilient to climate change than they are to invasive pests and pathogens?
Yeah, there's just mounting evidence that the temperate forests of the world, so the forests here in Eastern North America, Western Europe, and the temperate regions of Asia, particularly Japan and Northern China, are likely among the most resilient to climate change of any ecosystems on the planet. You have to remember that our northeastern tree species have evolved over millions of years for their tolerance of highly variable climates. That's what, in fact, defines a temperate climate. To the north, the boreal forest, it's cold. The tropics, it's warm. Here, it's warm one day, and 2 days later, it's freezing. So, that fluctuation has been a common thread in what they have to adapt to. And in fact, some of my most recent research on forests here in the Northeast, as well as with colleagues in Western US and Europe, indicates that temperate trees have a really distinctive capacity to adapt to local climate conditions. Now, we don't know if this is genotypic, and the trees here in Millbrook, the maple trees, are genetically different enough from the trees in Maine that maybe they don't have the capacity to respond, or is it phenotypic, and that a tree just adapts over time to the climate it experiences during its lifetime. Mm-hmm. And colleagues and I have done some really extensive studies of the sensitivity to variation in climate across the entire life history of eastern tree species, from seedlings to mature trees. And the bottom line is really pretty simple. And it's that mature trees and even saplings of almost all of the eastern tree species are remarkably resistant, at least in terms of their survival, to even fairly dramatic variation in mean annual temperature. Seedlings, on the other hand, are highly sensitive. And so our models and analyses, as well as those of most other research groups, conclude that it takes 1 to 2 generations before you see significant changes occur in response to the climate change that we know is already occurring and will accelerate over the coming decades. And since tree generation times are on the order of 100 years, major changes in the distribution and abundance of our tree species is likely to lag climate change by 100 to 200 years. And the graph there shows the distribution of where trees are present along climate gradients of mean annual temperature. The dotted lines sort of bracket the 9 northeastern states. And another distinctive thing about our species is that they occur across pretty broad ranges of climate. So, there will certainly be dramatic changes, most immediately in some of the northern conifers like balsam fir, which really can't tolerate, balsam fir could not survive in the climate here in Millbrook. Its survival just drops like a rock. Mm-hmm. But even, in 200 to 300 years, we predict really quite pervasive and dramatic changes. It just takes a long time to play out and means that these forests are always lagged and out of sync with climate. And, having said that, there are lots of caveats and provisos here. This is what I can expect based on all the current evidence, but there are a lot of things that make me question just what could happen in the future. We just talked about pests and pathogens. Right. And there's very good reason to think that climate change could result in serious outbreaks of not just new and introduced pests and pathogens, but some of the many native forest pests and pathogens in the Northeast. So, in the North American continent, the most devastating forest pest outbreak in known history over the overall history is arguably the mountain pine beetle outbreak that has attacked so many species of pines in tens of millions of acres in the Western North America, US and Canada. But this is a native insect, and there's compelling evidence that the climate warming, which has been quite strong in the Rockies over the past several decades, has contributed to this massive outbreak. So, trying to predict the future is, particularly when the world is changing as rapidly as it is probably a fool's game, but it's important that we try to at least think about all the different currents that could shape the way forests will change.
Yeah. So Charlie, you've talked about humans cutting trees down, insects and rusts and other invasive, introduced pests and pathogens, killing off entire species, and that would create an opening. And because the young trees, the saplings, are so sensitive to climate change, you then might get a recruitment or a growth of other trees that are slowly moving up and being dispersed either by wind or by birds or by other forms. And so you end up with climate change not being necessarily the direct, but as is always the case, these things build on each other. And they end up, the system is not unimodal and just deals with one threat, then another threat. These threats sort of intersect and interact, and that's probably what makes predictive science so difficult. So, Charlie, thank you. We're going to go to questions. We've flown through this. And, when Charlie and I started discussing what we'd cover, there's so much more that we could have covered, right? You've got the role of white-tailed deer, the impact of fire suppression, which we sort of referenced but didn't really talk about. And Charlie talked a little bit about how changes in land tenure and forest ownership affect forest management. But there's so much else we could talk about. So let me give Charlie the last word, and then we'll go to Q&A.
Okay, I hope this doesn't sound trite, and I'm very fond of my cheesy nautical metaphors. I have to say, I've taken up boat building as a hobby in the last 4 or 5 years and thoroughly enjoy it. So, the forest may be adrift, but I remain optimistic that they'll stay afloat. And I just want to say a word of thanks to 2 people in particular. This book took a while to write. It shouldn't. It's a very short book. But it was really because of the work and the encouragement of 2 people. Jean Thompson Black, who's the senior biology editor at Yale University Press. Jean heard me give a talk at a conference, and then I ran into her at breakfast the next day. I've known Jean for many years. She's a PhD ecologist by training, and she suggested I think about writing this book. I thought, well, I'm flattered that you asked me to, but I kept putting her off until I met Amy Goldman Fowler on one of my forest walks. And it turned out she was a neighbor and was interested in learning more about the forest at her farm and working on a book, one of the many of her spectacular books. And it was really only once Amy kept sort of prodding me that and through, frankly, the support of the Lillian Goldman Charitable Trust to help underwrite the cost of the book and the work in the book, that I finally agreed to do this. So I'm eternally grateful to both of them.
Great, and Jean has given us a discount code for ordering the book. You have to order it from the Yale University Press website. It's up on the screen now if you want to write that down, and we can also post it to those who have signed up. We've got a couple questions. It's interesting. People really care about oaks. So the first question deals with oaks being an intermediate shade intolerant species and needing some level of open canopy. So, how were oaks dominant so long if you had this, mature old growth forest that was so shaded? How did they recruit themselves back in? And, why do we keep the forest, and how do we keep the forest oak dominant when things like maple and beech are growing under the oak canopy instead of oak saplings?
Well, I still remain a believer that fire was important in maintaining oak dominance over that 8,000 to 9,000 year period. For many years, we blamed the fires on Native Americans. There were early writing from the early explorers that claimed that Native Americans were deliberately setting fires. Emily Russell Southgate, in her wonderful book on historical ecology, also published by Yale Press, does a pretty good job of debunking this, pointing out that in none of those early writings did anybody claim to have actually seen a Native American setting a fire. But there's charcoal all through the lake sediments. And one of the reasons that that fire is such a likely role here is that, you know, mature large oaks have very thick bark and are relatively insensitive to a light ground fire, which is what we think was probably burning. Maples, on the other hand, are quite sensitive. One of the really interesting sort of inside baseball stories we discovered many years ago was that all of these trees can survive in the shade cast by their own adults. But if a more shade tolerant species is able to invade, and it will cast deeper shade than the previous occupant can survive. And so if you can keep maples out of the forest, a closed oak canopy is still light enough, and there's always death and turnover. And when those big trees die, they create big gaps. And the canopies may have been more open than we expect given fire. So, you know, unfortunately, we really, the witness tree records don't give us as quantitative a picture as we would like. So we're not entirely sure just how closed that pre-settlement canopy was. And, you know, in many ways, I would love to time travel back and see what that landscape looked like, because I don't think I will ever, and given the disappearance of most of the oak forest understory, I don't think I'm ever going to have any sense of how glorious that community might have been.
Yeah, and time travel is something ecologists fantasize about. I'm a mammologist, and I'd like to go back to Miocene North America. When we had camels, you know, camels and rhinoceroses and lions, and oh, it's fantastic. So we have another, that first question was just going back and giving credit to Sharon Petzinger. Ava Goodell, who's at the Millbrook School down the road, said she's interested in species that are both biocultural and ecological. So would you say that any of the Northeast tree species are keystones, both in the biological systems, but in our cultural systems or the cultural systems of Native Americans? So might northern red oak fit this idea, or any other species come to mind?
You know, I take issue with the notion of both keystone and foundation species in the book. I'm sure this will not make some people happy, only because, you know, these trees are like my children. I don't want to consider one better than another in any one sense or another. They're all unique to me, and they all have very distinct ecological functions. And so you know, hemlock is often touted as a foundational species, that it does create a very distinctively shady understory with often a deep organic layer. It's an important species for shade along trout streams, which is one of the reasons people value it so much. You know, but I would argue that, and so does that mean we should put more effort into protecting it from the hemlock woolly adelgid? White ash is rarely more than about 5–10% of a forest, but it has very distinct effects on soil chemistry and nutrient cycling. As I said, I'm very fond of white ash. I love the wood.
Have you met a tree you didn't like? A native tree you didn't like?
Okay, not a native tree, and there are even some non-natives that I think are quite lovely in their native habitat, of course. But so you know, Ava, I'm sorry if I'm sort of dodging your question, because there is so much natural history and cultural history about almost all of our tree species that you know, oaks are really unique in many ways for a lot of wildlife. Those acorns, the hard mast, the food resource, well, frankly, this shows up in our Lyme disease research, where we can predict the incidence of Lyme disease 1.5 years ahead of time from the size of the acorn crop, because of the cascading effects on the mice and the infection of the mice from the ticks, and the ticks then getting us. So, you know, oak forests are really distinctive. They are declining in abundance for a lot of reasons. If you really want to manage for oaks, fire seems to be a very difficult way to do that, and you probably should be talking to a professional forester about doing slightly larger than single tree gaps. The problem is that white-tailed deer just love oaks, and without controlling white-tailed deer populations, oak regeneration in the Northeast is incredibly problematic.
Well, Charlie, one of the other questions was specifically about deer. So do you want to riff a little bit more about deer?
Yeah, I have to confess that my beloved master's advisor, Ori Laux, another one of my heroes, I've referred to them as mountain maggots. So forest ecologists do not view white-tailed deer with any great love. They're, you know, the pre-settlement, you know, we only have a fairly crude estimate of their abundance prior to European settlement. And then they took a dive. So by the late 1890s, the New York Game Commission estimated that there were 12 deer, 12, in the entire Catskill region. And, you know, deer hunting was banned in New York from you know, the Catskills west from 1900 to the World War II. And so by any measure, you know, hunting laws and regulations have been extraordinarily successful at rebuilding white-tailed deer populations. They were extinct in Connecticut. They were reintroduced to Connecticut. Apparently a great mountain forest in Norfolk, where I've done research for many years. But there can be too much of a good thing. And you know, there seems little question that white-tailed deer populations are many times greater than they would have been prior to European settlement, and are concentrated in ways that make regeneration problematic. More than half of the forests in the Northeast have what I would consider inadequate regeneration, much of which can be attributed to existing white-tailed deer populations. And you know, there are just too many sides to the debate about, you know, deer hunters understand that with smaller deer herds, they'll see more healthy, larger deer, but deer hunters still want to see lots of deer, and they have a strong role in setting hunting management policies.
Right. But that's based on 40 years of data at the Cary Institute, where we've been doing controlled hunts, and lo and behold, you get oak coming up through the ground and not getting eaten.
So it is possible to do a controlled hunt that is really valued by the hunters.
Right.
But that also, if you have if you have 500 to 1,000 acres and you can get a deliberate hunt that's willing to take does, you have to be willing to shoot the does. You can bring the herd down to a level that still produces abundant deer and gives you good regeneration. It's just hard to do without being deliberate about it.
I'm going to try and squeeze in two more quick questions. So the first is, and this is a real softball for a Cary scientist, because it's about acid rain. And for those of you who don't know, Gene Likens, the founding president of the Cary Institute, was the co-discoverer and coined the term acid rain. And the question is, you know, 35, 40 years ago, we thought acid rain was going to devastate the Northeastern forests. So did it? If not, what happened?
Well, you know, I remember a headline in the New York Times in 1986, "Sugar maple faces extinction." I had just finished my PhD studying sugar maple and old growth forests of the Adirondacks, and compared to beech, it was the picture of health. And so, you know, the lesson here is that there was a period where there was an awful lot of dieback in maples and particularly red spruce. And there's very good evidence that this was triggered by the very high levels of acid rain and even acid fog at high elevation. It took a long time to work out exactly what was going on. There was a lot of money spent, but once the money was done being spent and people could, you know, really burrow down and do the careful work, the concerns about leaching of calcium from forest soils, too much nitrogen, making the trees not winter hardened properly. You know, but if anything, sugar maple and red spruce are more abundant now than they were then. Red spruce is coming up everywhere in the North Woods. Regeneration is so dense, it's painful to walk through, and the maples are coming into the oak forest. So, you know, it's important to put these things in context, and you know, it's natural when we see something happening to raise the alarm, and it's often only with a lot of very careful work that we figure out just how that might play out over time.
Right, and that was Tom G. The deer question came from Laura Heady. But you know, I just want to add in, Charlie, that you know there also was real change in the Clean Air Act revisions of 1990. Right.
Thank you. The obvious. I
so
followed the lead there.
yeah. So there was, you know, the discovery and the study of acid rain led to regulation that reduced acidity down to almost pre-coal burning levels. We're not quite there yet, but with coal disappearing, we'll get there. We hope fairly soon.
Yeah, certainly the decline in sulfuric acid, there's still been a lot of concern about the amount of nitrogen being loaded, but it is a remarkable story of the success of air pollution legislation.
Okay, we've got one from Evan Gora, who's going to be a research fellow at the Cary Institute next year. So welcome, Evan. You know, the shift in logging practices from the vertically integrated mills to investment firms suggests a real shift in the timber market. Is the supply market changing on its own, or does it reflect real changes in demand for harvested trees?
It's really hard to trace the importance of demand on logging practices. Certainly it happens. I often talk about the Martha Stewart effect. So 30 years ago, you couldn't sell red maple except as pallets for, for industrial use. And now red maple is a furniture grade wood because people prize light colored kitchen cabinets. You can hardly sell oak and cherry at the moment. And those changes happen on a time scale of 5 to 10 years. There was a very big drop in timber demand after the 2008, whatever we're calling that, recession, the little recession that happened 12 years ago compared to what we're in now, I guess. But that has gradually recovered. Foresters tend to be very concerned about the disappearance of markets for low-grade wood. So if you've got low-grade trees in your forest, foresters would love to be able to sell that and promote the high-grade wood. On the other hand, that low-grade wood is actually more valuable left in the forest as a carbon credit because it's still storing a lot of carbon. And so we need a lot of new work to look at how to craft silviculture that balances both meeting the market demand, but also meeting the ecological benefits of diverse forests and carbon sequestration.
Well, Charlie, it's interesting you managed to hit the second to last question from the Adirondack Land Trust, which was about short-term investment and management. So I think that last question did it. So we'll close with a question from Vanessa. It sounds like balsam fir will suffer as a result of climate change. Do you have a guess regarding how long balsam firs might remain in the iconic high peaks of the Adirondacks?
We actually, our models suggest less than 50 years. Within 50 years, we will see dramatic declines in balsam fir. The other big problem is that the balsam woolly adelgid and spruce budworm both loom as sort of the more immediate causes of adult tree mortality. And as winters get warmer and the mean annual temperature goes up, those less likely to regenerate. So, those are the species that we see the most rapid response in, and it's within 50 years. So, which, again, to a tree is no time at all.
Right. I mean, I remember when I first came to the Cary Institute, we were talking about this finding that short-term, 100 years, climate change may not be that important. You were a little worried about how people would take that. And I said, well, why is that? And he said, well, look, once a tree's an adult, it can get as high as 105. It can get as cold as -20 or -15. And that can happen in a 3-month period, right? And so that you made it clear that temperate is what these are. They're temperate trees. They're adapted to that. So do you have any closing words for us?
Nope. I want to thank everybody for tuning in. I really wish I could see you, and I really wish we could be together or basically out walking in the woods which is what I most love to do with the public and tell stories.
Well, forests may be adrift, but I think you're optimistic that they may stay afloat.
Absolutely.
Good. So we peaked at 402 participants. We have 360 still, which is quite remarkable. It's hard to find a silver lining in this COVID-19 pandemic, but it's made us much more attuned to the virtual world and the ways we can access information and connect with all of you. With over 400 people logging in tonight, I'm just amazed by that. We could never do that here at the Cary Institute. And it's wonderful knowing that you have all joined us, and even though you may not have known that we as an institution existed before this. So tomorrow, we're going to post something on the website, that's caryinstitute.org, which is the next Cary Science Conversation. It's a very different topic. It's about urbanism, and it's with Timon McPherson, who's a research fellow at the Cary Institute and a faculty member at the New School, and it's on extreme heat, COVID-19, and equity in New York City. So please go to the website to sign up for that. While you're there, you can poke around our beautiful new website, learn more about the remarkable work and the remarkable people with whom I have the pleasure of working. So I agree with Charlie. Thank you for coming. I am really sorry that I can't see all of you. Stay safe, stay healthy, and stay informed. We look forward to seeing you soon. Bye.